Okay, hello guys, my name is Rahul and welcome to the Hadoop training demo class powered by Vignity. And can you all guys please reply on the chat that you have on the right hand side if you are able to hear me. Please write on the chat if you are able to hear me. There is a chat option on your right hand side in this GoToWebinar tool that you can expand and type there if you are able to hear you. Okay, Abhishek says I'm able to hear you. Great. Neela Kurti says hi. Okay. Okay. Okay, great. So I have Mufaddal with me, and Mufaddal has been working on Hadoop like for couple of years and has like 8+ experience in the training and development section. He is currently working in Dell, and he has been conducting training for Yahoo. So he will be taking over from here. And Mufaddal, are you able to hear us? Please reply.
Uh, yes, Rahul, I'm able
Okay.
to hear you.
Okay, Mufaddal, let's come into the action and let's start the class, please. Okay.
Yeah, thanks, Rahul.
Okay.
Yeah. Hello, guys. Myself, Mufaddal. So, as Rahul said, I have been into training and all since 8 years, and currently I'm working with Dell R&D. Okay. And I have been training the new guys joining Yahoo and all for this particular big data, Hadoop, Pig and all related technologies, right? So we'll take a demonstration today, like what all are, we'll try to understand why we need big data tools, what is big data, and uh, what are the approaches that will help us, what were the traditional applications that were not helping us to analyze the big data, and brief introduction of Hadoop, what is HDFS, MapReduce, and the ecosystems. So are you guys able to hear me? Am I audible? Okay. So
Okay, sorry to interrupt
I
Mufaddal in
think
between.
it's audible, right?
Excuse me, just one second. To all the
Yeah.
participants, guys, you can write on the chat window that is present on your right hand side for any questions. In case you want to speak, we will unmute you. You just have to raise your hand. There is another feature for raising the hand. You just raise your hand, we will unmute you. You can ask your questions verbally and Mufaddal will be answering that. Okay guys, please type on the chat window. Yeah, Manoj, do you want me to unmute you? Manoj says I'm muted by the organizer. Okay, Mufaddal, you can go ahead with this and we will take that in between.
Yeah. So basically this is the agenda what we are going to see in this demonstration. Okay. So quickly we'll start off with our agenda. First, initially to present some interesting facts. So currently we have total around 2 zettabytes or 2 zettabytes of data over the internet. Okay, but the problem is we are not able to analyze all the data that is available on the internet. The other interesting fact which shows the amount of volume that people are handling and how they are facing the problems is if we take example of Facebook. Okay, so it already has 240 billion photos on its database, and every day it's adding up 350 millions again, right? But still, why Facebook is so popular? The thing is, even though the data is huge, but still the speed is what makes them the clear differentiator, right? And the velocity at which the data keeps on increasing, you can say like daily it has 2.7 million likes and 2.5 billion items which are being shared and all that, right? Another classic example what we can see is in US they have smart meters. So they have around 15 million smart meters across US, which is generating data at the speed of 3 GB per second. But still, they, all the data that is collected, they have to process, they have to generate the appropriate billings and all that based on whatever data they have collected. Okay. And one more, to take one more example, we have Google, right? So Google, whenever you type something on your on the search box, okay, Google will recommend you most appropriate searches according to your search words, right? So how does it do that? At the back end, it has trillions of pages, but still it is so fast. So what it does is it does a backend analysis, plus it is using indexing and big data technologies to achieve faster performance based on the amount of data they have. Okay. So if we move on again, if we say people might have, nowadays today everybody has a LinkedIn account, right? So whenever you log into your LinkedIn account and you view somebody's profile, like for say Mr. X, you will also see a sidebar which will be indicating that viewers of this profile also viewed some other profiles. Okay, so here they are using K-means clustering algorithm. So they are merging multiple data sets and forming an analytics and showing it on the sidebar, which gives you a proper link wherein you can go and connect to that particular person, and you can send a request for a professional purposes. One more example is like analytics or recommendation system. What you can say is, so whenever you log into the Yahoo homepage, right? So based on your previous search and the logs that you have generated based on your search, the Yahoo homepage will display whatever appropriate searches you made. So for example, every time you go and search for some cricket news, okay, so then the next time when you open your Yahoo web page, you will see cricket news at the first. So apart from this, if you take your YouTube account, so whenever you might have searched certain videos and related to certain topics, for example, it may be something related to big data or something. The next time when you log in to your YouTube, again it will show you big data related videos at the top, and it will recommend it. So that is what recommendation happens. But the recommendation, again, at the back end, it has to analyze huge set of data and it has to come up with some conclusion so that they can recommend it, right? So now quickly we'll talk what is big data. So basically big data is a concept, and to define big data we have three parameters saying volume, variety and velocity. So based on these parameters, we will come to know whether the data is really big or it can be handled by traditional applications or traditional approaches, right? So as we saw in the previous examples, if you take the data in case of Facebook or LinkedIn, so it may be very huge. So that covers the velocity, volume of the thing, okay? That covers the volume factor of big data. Okay, when you talk of velocity, so velocity is something, the rate at which the data keeps on growing. So again, US smart meter or the share market, for example, you can say that generates huge amount of data with a very short span of time. So that defines the velocity factor of big data. And again, variety. This is one a little bit different but a very important factor. So in this factor you have multiple kinds of data, saying structured data as well as unstructured data. So what do you mean by structured data? Structured data is something that we used to hold it traditionally, and we used it for traditional recommendation systems and traditional analysis. Okay, but the major part of the data is unstructured. So as you can see in this graph, the blue portion indicates your structured or relational data, which grows at a quite low pace, but when you go to unstructured or complex data, it grows at the exponential rate. So in the traditional applications, we didn't have any capability to analyze this complex and unstructured data. So it was as it is, it was a dead data, we were storing it somewhere. But we could not make any business sense out of that unstructured data. So then there was a problem there. People wanted to analyze that unstructured data as well, which was lying in their storage. So that is where the need arises, like how can we analyze this complex and unstructured data, right? So there were some big challenges with regards to big data. So the major challenge was the data that is unstructured is complex, and we don't have proper understanding what kind of data it is, right? So if at all you take structured data, what happens in structured data is first you define the structure. Maybe in your relational database you define a table with certain columns and the column types and the data types which you are going to feed in, and then you are going to feed the data inside your table. So that is quite simple. It is structured data and you know what the data is. But in case of complex data, you don't know what the data looks like, but still you want to analyze. So that was one of the challenge. The other challenge was storage. Like if you take example of Facebook, right? So in Facebook, you have every day they are adding 300 new servers. Okay, so what would happen if they go on increasing? Okay, so here also they have a problem. Like in the traditional applications, whenever you are adding one more machine to the cluster, you have to restart your entire application and add one more machine to the cluster. But that was not working out in case of applications like Facebook or LinkedIn, or else every day they have to restart 300 times. So that is not feasible. So that was a challenge. Again, performance. So the more the data, the more performance it would require, right? So performance again was a bottleneck for analyzing the complex and big data. So here we could see a traditional application wherein you have an application server and you have a database which is located somewhere in a remote location, or it may be in the same data center for say, right? So the majority of the time you want to analyze the data would go in the network download. So for example, if you want to analyze something called 100 GB of data. Okay, so what happens? It has to download 100 GB of data to the application server. It has to analyze it here, and again it has to put back 100 GB of data into database. So this was eating up 90% of the network bandwidth. Okay, so in this case, if you take if you put Facebook kind of applications in this scenario, you may take Google or Facebook. They are analyzing zettabytes of data per day or petabytes of data per day. Okay, so they will not be able to achieve that analysis in probably a couple of months also. So if some analysis takes more than a day, then it is not at all feasible to do that kind of analysis, because the next day the analysis might change. So that was the one challenge. So here we see network is a challenge, like the network eats up 90% of your time, plus you don't have a dedicated network line for your application. So it is a shared application or a shared network across the entire organization, and you cannot again control the data. Like you cannot say that per day will allow only certain X number of GBs to be updated or uploaded. Okay, so these are the challenges. So one interesting statistics we will take as an example. We are taking an ideal scenario of we are having network bandwidth of 10 Mbps and assuming we have all this 10 Mbps available. So then if at all our application size is 10 MB, that is on the higher side, again enterprise application code is not 10 MB also, right? But still taking an assumption or hypothetical data, we say application size is 10 MB, the data that you are going to analyze is 10 MB. So in the traditional application it will take 1 second to download, we are not considering the analysis time, and 1 second to upload. So the total round trip time will be 2 seconds. So when we go on increasing, the problem starts when it comes from 1 GB. Okay, so taking this ideal scenario, only downloading and uploading the data will take around 3 minutes. So imagine if you are sitting on web, sitting and you are surfing your Facebook. Okay, so if your profile loading takes 3.33 minutes, then how would you feel? You will get annoyed and you will run away from Facebook, right? So Facebook would not have been popular if it was not this fast, right? And if you talk about TB of data, then you just leave it. It's almost 55 hours only for network IO, that is download and upload. So what was the observation from the traditional application while handling big data was that 90% of the time was consumed in data transfer itself, and the application size anyways, like code, is not going to grow very much, right? So this was the observation. So then the researchers started thinking like what could be the solution. So we can see here is we have one application server here. Please pardon my diagrams. Yeah, we have a database here. Okay, we are taking 90% of the time is taken by this network. Okay, so how to avoid this 90% of the time? So what people thought is, we'll stop the network, we'll start running the application where the data is stored. Okay, so this is what exactly data localization means. Okay, so what happened is people started using this concept wherein you have an application server running where your data is stored. Okay, so this is what exactly data localization means. So that is what people started trying achieving it. So moving the application at the place where the data is residing, or making data local to the application, that was one conclusion drawn out. Okay, but again, when you bring your data to your application server, again you are raising two more problems. One is storage, okay, and the second one is your performance. You are raising two more issues here, because the storage on a particular server we cannot go on increasing the storage, and as well as performance will be a problem, as we are not going to increase a RAM after certain limit of time, right? So that was a problem. So that is what is listed here. Efficiency and performance of application is determined by how data is read. Again, what we are talking here is the read latency. Like if your hard disk is 1 TB, it will take more time to read the data than when your hard disk is 500 GB, right? And again, the bottleneck is the processor and RAM. The processor also you cannot go and change frequently, and RAM again, after a limited amount of RAM you cannot increase further. So these were all the bottlenecks here, right? So what observation we could make after data localization was, large amount of data will take a lot of time to read, and RAM also is a bottleneck, right? So these were the two observations, and if we try to summarize the problems, we have three. Storage was again a problem, cannot store large amount of data, and every machine can upgrade up to certain limit of storage. After that, the hardware will not support. Yeah, so we also have hardware limitations. Again, the more the data you store, the more the performance will degrade. So that is another problem, and large data sets will take large amount of time to read. So if we summarize, when we do data localization, again we have three more problems. So then how to approach that problems is via distributed framework, right? So now we are thinking of multiple machines attached to a cluster, and each will have its own storage and application, right? So that is one thing which we can think of to solve storage and performance issues. So we'll take one example here. For example, if you want to store 10 TB of your data, but your server hard disk is only 500 GB. So what will you do? Okay, so one solution is you go and upgrade your hard disk. Okay, but there is a hardware limitation. You cannot increase more than certain limit of hard disk. Okay, so what this guy is telling is, so it has hardware limitations, so you cannot go and upgrade your hardware or hard disk. So what the suggestion comes out is, you have multiple machines which can store data, so that your 10 GB of data you will break up into multiple parts and spread it across multiple machines, right? So here we are adding more storage. So if at all some more machines are required, I'll add more machines for increasing the storage. So this addresses my storage problem. But again, in the backend it is also adding more CPUs, because we are adding more machines. So each machine will be having its own CPU and RAM. So unknowingly, while adding the performance in form of a distributed framework, we also add, when we try to add more storage, we also add performance here, because it has multiple CPUs here, right? And it can utilize it parallel. So what we have achieved till now is, via data localization, we achieved network I/O. Okay. Via clustering or distributed framework, we achieved storage. And one more thing we achieved is performance in form of more CPUs and RAM, right? So this is exactly what Hadoop is trying to achieve. So if we try to form a formal definition of Hadoop, Hadoop is a distributed framework which provides scaling in terms of network I/O, storage and performance. Okay, so that is what exactly Hadoop does, right? So now if you try to recall, we had multiple challenges in terms of handling big data, storage, performance, and there was a network I/O which was eating up your time. So all these problems are addressed using Hadoop. So Hadoop, we can say it is a tool or a distributed framework which provides us a lot of features to handle big data, right? So some of the features are listed here, like Hadoop brings in data availability, data consistency, data localization, and data accessibility. So if you fuse all these conditions, we also have this in Hadoop. So that is what exactly Hadoop brings in, the additional features. Okay, apart from storage, performance, and network I/O, it also brings this kind of features with it, right? So we'll discuss one by one all the features here. So if we say data availability, what it means by is each data should be available all the time. So what if out of this 3 machine, one machine goes down, right? So in Hadoop they have a mechanism for replication. So the same data is replicated across more than one machines. So even if one machine goes down, still it has data available on another machine which it can go and access it. So that is what it means by data availability. Now localization we already discussed. Okay, data localization. So wherever the application is running or wherever the data is residing, we will go and run our application on that machine. Right? So that is what data localization means. So behind the scenes what is happening is, one big file is there, you try to put it on Hadoop's distributed file system. What it will do is, it will break up into multiple small parts and store it across multiple machines. And each part or each block of data is replicated across multiple machines. That is, here we have shown 3 replicas for each. Okay, so the same data is replicated across multiple machines to achieve data localization as well as availability. Right? So this is what indicates the data localization. So we have our data on these machines. So we'll go and process or execute the task near to the data. So that is what this slide indicates. So yeah, running your application close to your data. So now if we are designing a new framework, then what all things we would like to have in this framework. So it should be like, it should support partial failure. Like if we have multiple nodes, if one node fails, then it should not say that the entire job has failed, because when we talk about a clustering environment with regards to big data, we mean 100+ nodes. Okay, so imagine if one node has failed and 99 has succeeded. So you will get annoyed if one machine fails, you say the entire job has failed, that people will get annoyed. Okay, so it should support partial failures. It should support recoverability, data availability, consistency, data reliability, and upgrading. We'll see one by one what it is. So when we talk about supporting partial failure, we say that the system should not shut down the entire system if few machines are down. So if some nodes are down, it should not, the entire system should not stop working. Yeah, the point of fact is the performance may decrease because we are having less number of machines to process the data. That is fine. But that is what it means by supporting partial failures. When we talk about recoverability, if machine or component is failing, the same task should be taken up by the other machine so that the entire job is not failed. Right? So that is the capability, like the network or the Hadoop cluster is able to recover the loss that is done by one of the machines going down. Right? So the task is shared or it is taken up by another machine which has the same data available. Right? So again we discussed data availability. If one machine is failing, then it should not result in loss of data. The same data is available on some other machine in terms of replication. So it should be always available. So that will help us building a fault tolerant system. Okay, when we talk about consistency, the data, what we give out as a result, right, that data should be consistent. Like I will want to give one example here. So if you have 3 machines, okay, doing some summation or summing up some data or profit of some organization, like you have quarterly and yearly reports of profit from each organization. So for example, machine 1 is calculating profit from US, machine 2 is calculating profit from EU, and machine 3 is calculating profit from APAC for company X. Okay, so now what happens if machine 1 fails and it doesn't give output, and machine 2 and machine 3 succeeds and it gives the profit? So it would not be correct if we give the output from these 2 machines. We want the output from all 3 machines to get a correct data. So that is what it means by consistency. So in this case it should say that the job has failed, or else what it should do is it should give this task to machine 4 and it should analyze and give the data along with these two. So that is what it means by consistency. So the data should be consistent. If at all you are not able to analyze it by any means, or you tried some 2-3 times and it still failed, then you should say that the entire job has failed and it should not give incorrect data. That is what it means by consistency. Reliability means the same as consistency. So the data integrity and correctness should be at the place. So it means almost the same. And this is one important point. Upgrading. Upgrading should not be a problem here. So now in the traditional distributed systems, if you go and check, what people have to do is, if I want to add one more server to the cluster, I have to stop the application, I add my server onto the cluster and again restart my application. But that should not be the case. Simply I should add one server to the network and it should be able to identify that, okay, this is the new node that is available for our cluster, and it should accept that entrance and it should start working. So that is what is expected. If we don't have this kind of behavior, then imagine big shots like Google or LinkedIn, they have to add multiple servers in one day. So if they keep on restarting their system, there will be a huge downtime. So that is not an expected behavior for big data tools, right? So that was something what was expected from a big data tool like Hadoop or whatever it is. So now we'll talk about some introduction. We'll take about what Hadoop is and what it is able to provide, what are the capabilities and all that. So as we have seen that Hadoop is a distributed framework which provides scaling in terms of storage, performance and IO bandwidth. Okay. Again, along with that, it brings in lot many features, like it is a fault tolerant system, it is an open data format, it has flexible schema, it doesn't delete data anytime, you don't have any APIs to delete the data. Then it has its own file system known as HDFS, it has a queryable database, has archival storage and many more. These are a few which I have listed here. So when we go to the history of Hadoop, so first it started with a Google file system. So Google published white papers regarding Google file system, GFS. In 2005, Nudge came up with a processing framework called MapReduce, which was used for analyzing data from multiple machines. Right? In 2006, again there was a Lucene project which was only meant for searching the data from the documents or indexes. In 2007, Yahoo clubbed this Google file system and the MapReduce framework, and it modified a little bit, which we see today as Hadoop. So Hadoop is the Yahoo guys clubbed HDFS and the MapReduce and formed Hadoop. So they were able to test it on 100 node cluster in Yahoo, right? Then they made it an open source top level project in Apache, and then in 2008 again they were able to successfully test on 4,000 nodes of cluster. And one big achievement which opened the eyes of the industry was that Hadoop was able to sort a petabyte of data in 17 hours. Prior to that, which was not possible, which the traditional applications or the other applications which were there at the time were not able to sort it, or it was not possible. So that was an eye-opener. So that is when people started looking towards Hadoop as a big data tool and a very fit contender to analyze big data. Right? So now something you want to see is who all are using Hadoop. So I have listed some of it, like Google, Amazon Web Service, Kaggle, HP, IBM, EMC Square. EMC Square has modified its own Hadoop and giving it out as a product called Greenplum. Cloudera, you are aware of it. It also provides its own distribution of Hadoop. Hortonworks, Yahoo, and many more like Teradata, LinkedIn, Twitter, Hadoop. And if you want to see more, you can check out the link that is provided at the bottom of the presentation slide, right? So this all big shots are already using Hadoop, and they are some or the other way taking the analysis work from Hadoop, right? So yeah. So, do you have something like what is your understanding regarding or prior to this session, like what would you expect from training from Hadoop, or what was Hadoop? Anybody want to share their views? Nobody? Or anybody had some idea regarding Hadoop, or something got clarified, or you want to know more something about Hadoop, which this demo session is not holding, or the basics of Hadoop. So anything related, or what is your expectation from this training? Anything you want to share? Yeah. So I feel people are getting it what I am trying to say. So now there may be one question like what is making Hadoop so special? There are multiple products like Teradata, or something provided by Oracle Labs and all that. But why, or if you say IBM mainframes is already there in the market for a long time. So why Hadoop is so special? So the major reason behind Hadoop to be very special is it is built on commodity hardwares. Okay. So what do you mean by commodity hardware is, if you don't have, if you are a startup company, for example, you want to start analysis, so you don't have to invest on mainframes, or you don't have to spend a lot of money on Teradata servers and all that. Simply you can add multiple laptops or desktops or servers, and you can start creating your own Hadoop cluster. You can start your analysis. So it doesn't require any special hardware. The other reason why it is more popular is it is an open source, and it can run on Linux, Mac, or Windows, or any other flavors of Linux like Solaris or HPUX or Ubuntu or anything, right? Plus it is more cost effective as it is an open source. It doesn't have any licensing issues and all. It is fault tolerant system, highly reliable and efficient storage system. Like storage, we already see. If you need more storage, you just go and add one commodity hardware and you are done with it. Also, it has a built-in intelligence for speeding up the application. That is known as speculative execution. So what happens is the master process speculates that the task is responding very slow. So it speculates it might fail, and it will start the same job on one other machine. So at that moment of time, there two machines will be executing the same task, and the machine which replies back first, it will take the output from that machine and kill the other machine. So this way it saves a lot of time. So this is one mechanism called speculative execution, which we'll discuss in more depth when we go forward with our training. Okay, and the other advantage is it is fit for a lot of applications. So some of them are weblog processing. So if we see weblog processing, Google's recommendation system is all built upon weblog processing. So whenever you log to Google or you are doing something, every URL that you search, it is logged somewhere, right? If you are logged into Google account. So then it will do all these recommendations or your search, it will give based on your search histories and your log histories, right? So the other thing where it is used is page indexing. There are a lot of indexes that are created for a faster searching and all that kind of applications. So it is very useful there. Again, if you are handling some complex event processing, so Hadoop may be very useful there as well. So these are some things which is making Hadoop having an edge over the competitors, right? So some features of Hadoop, if we are trying to discuss, is we have partition and distributes the data. So what Hadoop does is, if you try to dump a big file onto HDFS, what it does, it partitions the data and distributes across multiple machines in forms of blocks. Okay, and the other point which we can take into consideration is the data localization mechanism. So data localization is somewhat, you can say, it is the heart of Hadoop. So this is the concept where it gets the performance maximum. So it maximizes the performance. Okay, and it does the processing parallelly on multiple machines via MapReduce framework. So that is one more feature that makes Hadoop very fast and very quick and very appropriate for analyzing big data, right? So you might be having some questions like, if at all I am from an Oracle background or SQL background and I have around 10 to 12 years of experience in it, I don't want to learn Java. So, but still, if I want to use Hadoop, then what should I do? So the answer for this is, you can go and use Hive, right? So Hive is a high-level abstraction over Hadoop, which will give SQL-like interface. So what internally it will do is, it will convert the SQL queries into MapReduce and for you, and it will run on Hadoop cluster, and it will get the output from MapReduce, and it will again return it back to you in Hive. So that is what Hive does. So again, the same thing if somebody is from C++ background and they already have some programs in C++ and they want to leverage the power of big data or Hadoop, then they have an abstraction called Hadoop pipes. So via Hadoop pipes, they will submit the jobs in C++, it will be converted into MapReduce and it will be run on HDFS. So also, if somebody from statistical background, anyone from the audience? Anybody from statistical backgrounds? No, I guess. Yeah. So if at all anybody is from a statistical background, right, then they can use R Hadoop or R Hive, which is available, which creates a hook from R to Hadoop. So what happens is, when you type in the commands in R, it will be converted to MapReduce job and it will get the output according to R framework, right? So if at all somebody is good with Scala or Python or Ruby or that, they can go and use Hadoop streaming. So these are some of the hooks. There are multiple more which day to day are coming up. So we can go and use Hadoop in multiple ways, right? Again, moving to some of the challenges, like none of the applications or the frameworks can be perfect. It has its own cons. So we'll list some of the security, some of the challenges. So the first one what we are trying to discuss is the security part. So the security mechanism for Hadoop is not up to date. It uses a protocol called WMI, which is not recommended or not very secure. But the workaround what we have is we can put the cluster behind a firewall, right? So once we put it behind a firewall, it is somewhat secure, right? We already have a security mechanism implemented on the kernel side known as Kerberos, but still it is very tricky and people have to do a lot of complex things here. So people will say that firewall is a better option rather than going for Kerberos. The other challenge that we have is the deployment. So if at all you are using an open source Hadoop, right, which majority of the people are using, so you have to go and install Hadoop cluster manually on each machine, right? So what if you have a cluster more than 100 nodes? So in that case, you have to go and install it manually on all nodes. But again, you have Cloudera Manager free edition, which will allow you to install Hadoop until you have 50 nodes. If it is more than 50 nodes, you have to buy a license for it, right? So there is a workaround. Like Hotermux also have its own manager. Cloudera has its own manager. So if you are going for an enterprise application, this can be avoided using this licensed software or the distributions, right? The other challenge is maintenance. Like if at all you want to see which machine has failed, the only thing which you have in your hand is you go to that machine, you see the logs, what has gone wrong. So that is again a tedious job, but again, yes, Hadoop is maturing, so people are coming up with the solutions for this as well. So maybe in some amount of time we should see all these challenges being solved, right? So
Sorry to interrupt in between,
debugging is a must.
Mufaddal.
So when
Sorry, actually there are a couple of questions there. Can you see the questions window? I don't think so. Please check the questions window. There are a couple of questions asked by Manoj and Shaktivel. Can you please reply to those also?
I'm not able to see.
Can you click on the GoToWebinar icon there and open it and see on the right hand side? If you are not able to see that, you can click on view from the options menu and you will be able to see the window and questions window there.
Okay, let me see that. I don't have that option, Rahul.
View questions, you don't have that?
No, I don't have it. I saw your message, but I don't have that window actually.
Okay, let me just carry those questions. Manoj asked how is MongoDB, Cassandra, they are different from Hadoop? This is the question from Manoj. And Shaktivel asked, with all these four mechanisms, would they provide the same outcome in the challenges the previous slide?
Okay. So taking to the questions regarding MongoDB, Cassandra and all, right? So MongoDB, Cassandra, HBase are all kind of NoSQL. So it is almost separate from the concept of Hadoop. So what HBase is doing is, NoSQL is something like inverted RDBMS. So in RDBMS traditionally we have a row-based approach. Okay, we have multiple columns, but we query on rows. At runtime, we will not be able to add any more columns to the tables, right? So that was not giving us the scaling in terms of whenever I implement a new functionality in my application, I need to store some more data or a new column. I have to drop the table, I have to create a new table and reload all the data into the table. So that was the problem there. So the people inverted the approach. Now they made it column oriented. At the run you can go and add the columns and you can query based on unique row values. So that is what it achieves scaling in terms of it gives horizontal scaling. So as and when you want to add new columns, you can just go and add it. So MongoDB is kind of a NoSQL which is a document database. So basically what document database means is it will be directly mapped to the objects. Like if you are programming in object-oriented programming like Java for say, right? So document database is something like it will be representing a JSON object. So in JSON object you will have a key, a value, so the name of the property and its value. So directly it is very easy to map it to the object oriented thing, and it will be indexed. So the MongoDB or even if you say Elasticsearch, so that all are column oriented. Again, in NoSQL there are multiple types. HBase is a column oriented database. Again, MongoDB is a document database. So there are multiple types of database technologies. Again, when you try to relate MongoDB or for say if you take HBase as an example, so what HBase does is it has its NoSQL interfaces, but for storage of the data it uses Hadoop's HDFS. So by doing this, what it achieves is it has the storage can be expanded as and when needed, and again it is like querying mechanism is faster, so that you can get the data stored across multiple machines, you can get it faster and you can go ahead with it, right? So the other question maybe is with all the four mechanisms, so sorry, like I missed what four mechanisms we are talking about. So can we just have it, Rahul?
Hold on, let me just. Yeah, he was talking about Hive, and can you go one slide back? Yeah,
This one.
these four. Yeah. So
Okay. So what's
the
yeah.
question is, will all these four mechanisms provide same outcome?
Yes, yes. So all this mechanism will give you the same outcome, because the principle of Hadoop is the data should be consistent. So why it will give the same outcome is because ultimately everything will be converted to MapReduce and it will give you the same output. So the only thing to make it easier for the people who are not very much familiar with MapReduce programming, what Hadoop developers did was they created a high level abstraction called Hive for SQL kind of guys. For C++ background guys, they have Hadoop pipes. For statisticians and data scientists, they have R-Hive or R-Hadoop. And for scripting languages, they have Hadoop streaming. So ultimately, whatever code you write either in C++ or SQL or your R tool or your scripting, it will be ultimately converted to MapReduce and it will give you the same output. Yeah, again, if your logic differs, it may be interpreted in a different way, right? So it all depends on your logic, but if at all the logic is same, it will give you the same output. So does this answer your question? Okay, fine. So Rahul, if more questions, you just interrupt me and let me know.
Yeah, sure, I will do that. Please go ahead.
Yeah. So now quickly we'll see one thing. These are just charts indicating whatever industry is using. So by industry, if we go, banking is using the majority, like 25%, 15% in service and so on. If we go by the region, obviously North America is the dominating region with 59%, followed by Europe and APAC. So if you see by the industry, 63% it's used by large scale industries, 25 by small and mid-size, and government project 12. So fortunately, we also, Indian government has one project on Hadoop, that is UIDAI. So whatever the Aadhaar cards, they are using that Hadoop for storage and analysis purpose, right? So I think now after a bit of theory, we'll go to some practical implementations. So here we'll try to see a simple word count problem. So you might be thinking like word count, it's a very simple thing, but no. If you see the use cases, Google's recommendation is somewhat based on the word count. So what Google does is, it will maintain all your search histories, it will have its own keywords, then on your search history it will count that keyword, how many times it appeared. Okay, so based on that it will recommend you some videos in YouTube, or it will recommend you the sites which are more appropriate for you. So for example, word count they will use for region division also. So for example, if a guy from India is searching for some kind of electronic gadgets, it will show the Flipkart's thing first, rather than going to some American sites which are more popular e-commerce sites in US and all that. So all that kind of recommendations they do by the number of hits or the number of keywords that the user is doing while searching the web. So we'll see that. We'll take a small or a live example.
Okay, sorry. We have Ahmed here and I have unmuted him. Ahmed, you can ask your question, please.
Yeah, so basically my question was in the slide that you showed previously on the industry usage of big data. So telecom industry was not mentioned. So is it that the telecom industry is not using big data services, or?
No, Ahmed, the thing is, I have not mentioned each and every sector or verticals. Telecom industry, definitely it is using it, because I myself was working prior to this, I was working with Alcatel-Lucent. Okay, so we had customers like Bharti. Hello?
Yeah.
Yeah. So what Bharti Airtel and all they do is, they will analyze the usage of each user. So for say they will analyze like your data usage for past 7 months or 1 year is near about 1 GB, but still you have a plan of 500 MB only. So they will take that, okay, your optimum use is this many 1 GB, and your ISD calls are this much, but still you have the plan that is on the lower side. So they will suggest that, okay, if you go for this plan, or this is some scheme that will give you a discounted price. So that is how they build the customized plans. So definitely telecom industry is using it. I myself has used that for alarm management when I was I also worked on a project with Ericsson Ireland. So in that I was working with an NMS and alarm management and all that. We were doing that using big data. So definitely telecom is using it. So if you see the slides, I have not listed each and every industry. I have taken some examples just to give an idea.
Yeah, got that.
Yeah.
We can, yes, sorry, we can go ahead with the example you were showing, yeah.
Yeah. Okay. So we have already discussed what the use case of word count might be, right? So we'll try to see that. This is my project wherein I have I have my 3 files. Simple, one is my word count driver, mapper class, and the reducer class. So I will export it. Okay, I'll browse it, I'll keep it on desktop, and I'll say sample word count dot jar. Okay, I'll finish it so that this word count is exported on my desktop. So now I have this jar file here. Now initially I'll start my Hadoop cluster first. So quickly starting off my Hadoop cluster. As you can see, multiple daemon processes are starting, like name node, data node, secondary name node, job tracker, and task tracker. So I'll check the processes that it started all. So I can see all the 5 processes here. It started. Now, before firing a job on the cluster, we should see whether Hadoop is out of safe mode. Yeah, so now the safe mode is off. So first we'll find out on which file we want to Hadoop fs-ls. So these are all the files on HDFS. So where we want to do the analysis on. So we'll take one file, like first we'll see what the file contains. Cat okay, so this is the file. It's a CSV file. I think this will not be able to see it properly. We'll see some other file, or we can create some file. Okay, so here if you can see, we have Sharma shown some names and corresponding last name. Okay, so Sharma Som, Mishra B, Sharma XYZ, Sharma DEF, Mishra DEF. Okay, so we are trying to count how many times Sharma came, how many times Mishra came, Som, B, XYZ, and all that. Okay, so taking a very small data set, we are trying to achieve it. So now I will say Hadoop jar and the jar file name, sample word count.jar. Then I'll give the driver class name. So driver class name should be this one, Hadoop driver. Insert this one. I didn't copy it, sorry. Okay, then the input file name is what we saw. And the output directory name, what we want to give is demo word count. Okay, so before doing this, I wanted to open the UIs so that you guys have a feel of what is going on in the backend. So it will take some time, but still it is good to wait for to see the output. So now you can see this is the name node UI, wherein you can go and browse the files on HDFS, right? So we are into home training, and this is your map reduce UI. So currently we see running jobs as null, right? Now we'll start this triggering the job. So it started map 0%, reduce 0%. So if you go here and do F5 here, the job will come. So running jobs is this map percent completed 0, reduce 0. So this you can also see from the terminal. Now map is complete 100%. So if you do an F5 here, you will look at it in the UI. You keep on doing it. So once the job is complete, we'll go to HDFS and see the results. So now the reduce is complete. Okay. So now it went from running job to completed jobs. So as you can see here, if you want to see the job logs or whatever task it did, you can go and see in this UI what time it took and all, and the graph. Okay. So the same thing would be outputted on the console as well, but again it's good to see in the UI. Now we'll go to our results. So here we created an output directory called demo word something. So it should be here. Okay, I have to do an F5. Yeah. So when we see the date, it is today's date, 9 and 7 p.m. When we go to this directory, we have the success logs, whatever logs are there, and part file is the result files. So here you can see Abhi has uttered one time, Def has occurred twice, Mishra twice, Sharma has come 3 times, Som has 1 time, and XYZ has 1 time. The same thing if we run for a higher or a huge file, it will give us this result in the same fashion. So this was a sample application that we ran. So here we could see the job is completed and all the information regarding that. So that was something from my side for this a small demo on what we are going to cover and what we are trying to achieve via using this Hadoop tool. So you guys might have any questions, you can just put over to me and I will try to see.
Okay guys, so if anyone is having any question, just okay, Ahmed has raised his hand. Let me unmute him first. Yes, Ahmed, please tell me. I mean to say, please tell Mufaddal.
Okay. So basically, this was a good sample application. Now, if you can extrapolate this example to some more some live scenario. So how could we map it? Like, let's say, what I mean, can you give some real life example that you might have solved, so that will help us relate to what you did right now and what could be possible using infrastructure?
Yeah. So the thing as we discussed, like we have multiple log files, right? Like as I said, Google recommendation systems. Okay. So we also have in Dell we have our own recommendation systems. Like in our case, we have log files regarding the hardware status or the data center tickets raised and all that in one file. So we'll see that which hardware version number, for each hardware there will be a serial number. Okay, so there will be a huge file of it, which is in terms of TBs, because we get the data from multiple data centers. So it is in TBs. So we go and get what all problems are raised for a particular version of a network card, for example NIC, correct? So we get the kind of problems that we have, and we count the number of problems that we got on that particular card. So then it goes to the QC. The QC will contact the vendor which is providing the NICs, and we can get a better quality, or we can give a feedback, or we can discontinue the users. So it helps in taking the business decisions as well. So this is one thing what myself is doing currently for improving the quality and helping the business to get some more insight on what product we are giving to the customers, and what is the level of customer satisfaction, right? Since we don't have that production data on my side, but the same thing can be applied, you can tweak it based on the keywords, and you can get the output. So the same thing can work, can do many things in the production if you have correct data.
Okay.
Okay, now we have Manoj who is asking a question here. Let me just repeat his question. Sir, Pentaho BI suite has a Hadoop support, so do we use MapReduce job or Pentaho job? How do we go about distributed file storage using Pentaho? Let me just pose this question to your chat also, if you can see that. Manoj, let me just unmute you. I have unmuted you, Manoj. You are muted from your side. You can ask your question verbally in case you want to.
Yeah. Manoj, for your question, the thing is, whenever you have a hook to Hadoop, okay, it doesn't have any like availability, like it will go and run the Pentaho jobs on it. It will always be converted into MapReduce, and it will run, because Hadoop doesn't understand any other jobs than MapReduce. So that is why Hive, again, if you take example of Hive, if you write SQL queries, again it will be converted to MapReduce. If you use R-Hive, the R programs will be converted to MapReduce. So similarly, if you are using Pentaho BI suite and it has a hook to Hadoop, obviously it will be running a MapReduce, or the Pentaho jobs will be converted to MapReduce and will be running on Hadoop cluster.
Okay, we have another question here from, okay, Manoj says problem with mic, okay, no problem. We have Kishore here, and Kishore would like you to go over the slides quickly if you can.
Okay.
If you can,
So,
yeah, go over the slides once again very quickly, and that would be great for all of us.
okay. So you mean from the starting?
Yeah, we can revise the important points and skip the slides which were not.
Okay.
Yeah.
Okay.
Also, in the meanwhile, guys, if you have any questions, you can post on the chat, or you can ask us to unmute you one by one so that we can answer you correctly.
Okay. So basically we went, this was the agenda of our session. So what is big data, what are the challenges, what were the challenges in traditional application which led us to development of big data tools like Hadoop, what is the new requirements, what are some introduction to Hadoop, some history and all that. Okay. So we went through interesting facts like Facebook is having a lot of data, like 240 billion photos and all that. Plus we had multiple millions and billions of likes and content sharing across Facebook. So they have to deal with huge amount of data, as well as the data keeps on increasing, so the volume keeps on increasing. Similarly, we had two more examples here, like US smart meters and Google's recommendation systems. Okay, so this was something interesting facts we were talking about. So now we are going to the users or the implementers which are using Hadoop. So LinkedIn, one beautiful feature known as if you are visiting one user's profile, you will also see that viewers who viewed the profile also viewed some other profiles, and it will recommend you some profiles to visit. Right, so it uses k-means clustering algorithm at runtime, and it is achieved using a big data tool like Hadoop. Right. Similarly, we were talking about recommendation system. So Yahoo analyzes the user's behavior, and it suggests related posts regarding it. Then we talked about the concept of big data. So big data is a concept wherein three parameters are involved prominently: volume, velocity, and variety. So volume, if we talk about, we have already talked of Facebook, like it has to handle some amount of zettabytes and petabytes of data every day, and they have to manipulate it, they have to display it, they have to run the analysis. So one of the analysis which comes to my mind right now is it recommends you the friends, right, the people you may know. So it has to analyze the entire your links and your friends group and all that, and it has to recommend. So that is volume. Velocity, as we said, US smart meter produces 3 GB of data per second. So the velocity is very high, that data goes on increasing. The other factor, but very important factor, is the variety. So variety, when we talk, is something about structured data and structured data. So in structured data, we have relational data which keeps growing but at a very low pace. But at the other hand, when you talk about unstructured data, it grows exponentially, right? So in traditional analysis, we used to leave out the unstructured data as it is, and we were able to achieve analysis only based on the relational or the structured data. Then we talked about some challenges in big data, like the data is complex. We don't have proper understanding of the unstructured data, what it is and how we can analyze it. The second problem was storage, and the third is performance, right? So if we have huge data, performance is again a bottleneck, how to store the data and the proper understanding of data. So if you see this slide, it describes the traditional application where you have one application server, one database. So if you have all your data stored in the database, when you want to analyze, you have to download that data from the database to your application server, you process it and again put it back to your database. So here the flaw was like network is eating up your 90% of your time. So if we take a normal example, statistics which we talked about was taking an ideal scenario where you have 10 Mbps of speed and you get total or full 10 Mbps when you are trying to download. So if you take in statistics, you have 10 MB of data to analyze. Only network itself will take 2 seconds of your time. We are not calculating the analysis time, right? So the problem starts when we go to 1 GB of data. Okay, so 1 GB of data when you are trying to analyze, only the network will take 3 minutes approximately for downloading and uploading the data. So that is quite a bit of time. So here we took one more example, like in a Facebook, if you are trying to load your profile and it has a lot of data and you have to wait for 3.3 minutes, then obviously you will not like Facebook and gradually you will stop using Facebook. But the popularity factor of Facebook is, even though it stores huge data, but still it is very fast. And if you go to 1 TB kind of thing, right, it is almost 55 hours. So that is not at all acceptable in terms of analysis. So if one analysis takes around more than 2 days, then it is of no use, because that analysis will be an older one, 2 days old. So nobody wants old analysis, right? So out of that, we observed that 90% of the time is eaten up by the network. Okay. and your application size is almost constant, right? So to avoid that, what we came to a conclusion that we can use a mechanism called data localization. So what does it mean is, you will run your application where the data is already residing. So in that case, we are avoiding 90% of the traffic, or the 90% of the time which is taken by your network. Okay, but by achieving data localization, again we have a few more problems, like the performance, and we have the storage problem. So if you see from the observation there, again, if you have only one application server, you have limited storage capacity, you have limited RAM. Okay, and if at all you go on increasing your hard disk, at some amount of time you will face a bottleneck with hardware limitations, and you will not be able to increase your hard disk capacity. And again, one more factor here is, the larger the hard disk capacity, the more time you will take to read your data based on the read latency, or the RPMs of the hard disk. So these were some of the problems. So to summarize it, we have again 3 problems. Storage is a problem. You cannot increase your storage. You cannot go on increasing your storage. The second problem was performance degradation. So if you have huge data to be processed on the same machine, then your performance will gradually go on degrading, and every time you cannot go and upgrade your RAM. And the third one is, reading large data will require more time to read. So that was the summary. So to tackle these kind of problems, people decided to have a distributed framework approach, wherein you have multiple machines which can store data and can process it parallelly. Okay, so this was the idea of a distributed framework. So here we took one example. You had 10 GB of data, but your machine has 500 GB of hard disk. So what will you do in this case? So there was a suggestion, I'll upgrade my hard disk, but yes, that is not possible because you have hardware limitations. You cannot exceed your hard disk beyond a certain limit, or else your motherboard or your RAM and CPU will stop supporting it, right? So that option is ruled out. So what other option we have is, we'll break up the data into multiple machines or multiple parts and store it across multiple machines. So that looks to be a good option. So when we add more machines, we also add more CPUs and more RAM. So when it is processed parallelly, when we try to add more machine for storage, we also add more performance, right? So that is what exactly Hadoop is doing. So when we try to achieve more storage, we are also adding more performance to the cluster. So that is what exactly Hadoop does. We discussed about multiple features that Hadoop brings in along with it: data availability, consistency, localization, and accessibility. So availability means data is available all the time. Even if one machine goes down, that machine has another replica which is holding the same data, and the data is available if at all one machine is down as well. So that is what data availability is. Data localization is something like running your application where your data is residing. So in the backends, if you go, one big file is broken up into multiple blocks, and each block is having multiple replicas, and each replica is stored in different machines. So when you try to run a Hadoop job or any of the job you submit to your Hadoop cluster, it will go and run where your block of data is available on the machine, and it will, by this way it achieves data localization. Okay, so running data closer to your, or running application closer to your data, that is what data localization means. So now if we are going for a new approach, certain requirements we would like to have in the new distributed framework is it should support partial failure, recoverability, data should be available, consistency, data reliability, and upgrading should not be a problem, right? So then we discussed one by one, like supporting partial failure, like if one of the machines in the cluster goes down, then the entire system should not go down. Somehow the performance might degrade, that is acceptable, but the full system should not go down. So that is what supporting partial failure means. Recoverability means if one of the task fails on one machine, other machine should be able to take up the job and complete it. So it should not restrict, like if one out of 100 nodes, if one node is not able to process it properly, then it should be taken up by another node rather than saying that the job has failed. So that is what recoverability we mean. Data availability, as we discussed, if one of the machine is failing, the same data is available on another machine and we should be able to get the data. So that is how we build a fault tolerant system. Consistency, again we took an example of a summation of the profits or the company profits. If at all it is happening on 3 machines, if 2 machines gives the output, then we should, and the third machine fails, we should not give the output from only 2 machines as we required the output from all 3. So it should wait for the third machine to give the output, and if at all it is failed for one time, it should try another time, and after a couple of times still it fails, then it should say that the entire job has failed rather than giving wrong data. That is what consistency means. And reliability talks about the same thing, right? The data should be correct when you give the output. And upgrading. So in the traditional applications, if you want to upgrade a cluster environment, what you have to do is you should shut down your application, you add one machine to the cluster, and again restart your application. So that is not acceptable in current scenario. So if you have some large scale applications like Facebook or LinkedIn, and they are adding some couple of servers every day, then they will keep on restarting and it will bring long downtime. So that is not acceptable. So what was expected from a newer system was, whenever I add a machine to the cluster, there should not be any requirement to restart the entire system. So that is what upgrading should be, very flexible. So then we talked about some introduction of Hadoop, like a formal definition, like Hadoop is a distributed framework which provides scaling in terms of storage, performance, and I/O bandwidth. And along with it, Hadoop brings in multiple other features like fault tolerance, file system, queryable database, open data format, flexible schema, and so on. So then we talked about the history of Hadoop when it started. So it started in 2004 with Google file system. Google published papers on Google file system. Then in 2005 there was a project called Nudge, and still it exists. So it was using MapReduce framework for processing the data. Then in 2006 we had a Lucene project which was very powerful in searching the data and indexing the data. Then in 2007 Yahoo guys modified the GFS, and they clubbed GFS along with MapReduce to form HDFS and MapReduce, and came up with a framework called Hadoop. Okay, so they tested that on 1000 node cluster and they were able to do that successfully. Then Yahoo made that open source project. In 2008 it was tested on 4000 nodes of cluster, and in 2009 it was able to sort 1 petabyte of data in 17 hours, which previously it was not possible for the systems to sort such a huge data. Then we were talking about some of the companies who are using Hadoop, like you could see all the big shots are listed here and more on the links on the below presentation, like Google, HP, IBM, Teradata, EMC, Cloudera, eBay, Dell, Twitter, LinkedIn, and so on. Right? So then we talked about what makes Hadoop very special. So the first point is no high-end hardware is required. It is built on commodity hardwares. Then it is platform independent, like Linux, Mac OS, Windows, Solaris, anywhere you can run because it is built on Java. It is again a fault tolerant system, highly reliable and efficient for storage. it has built-in intelligence called speculative execution. So the system speculates that that node might fail, and based on that speculation it will start the same job on another node to save time. So whoever replies first will take the input from that node and the other node process will be killed. And one more thing, like it was fit for a lot of applications like web block processing, page indexing, complex event processing, and so on and so forth. Then we were talking about some features of Hadoop. So what Hadoop does is, when it has a big file and when you try to put it on HDFS, it partitions the data into multiple blocks and distributes across multiple data nodes. It performs computation closer to the data, that is data localization, which we discussed already earlier. And it performs computation across multiple hosts parallelly, that is taken care by MapReduce framework. So then we were talking about, like, if at all I am not a Java guy, I am from a SQL background and still I want to use Hadoop. So do I have any solution for that? So yes, there is an tool called Hive which can be used. It gives SQL-like interfaces. It gives SQL-like interfaces which can be used, and it can be leverage the power of Hadoop. Again, from C++ background, if some guy is there and he still wants to leverage the power of Hadoop, he can use Hadoop pipes. Similarly, data scientists and statisticians who are familiar with R, they can always go and hook R with Hadoop, and they can run their R programs or R files on Hadoop. So if you are familiar with Python, Scala, or Ruby, again you have an option of Hadoop streaming available for Hadoop. So that was something which we discussed. Then we discussed the challenges we have currently in Hadoop. So with regards of security, there are some protocols which are not very much secure, but still Hadoop is using. So to cover that, we have a workaround in form of a firewall. So if at all our cluster is behind a firewall, then we are pretty safe. We already have a kernel-based security mechanism, but it is very complex to implement. So people move or fall back towards the firewall. Then challenge in terms of deployment. So you have to manually deploy onto each node. So if at all you have a cluster which is more than 1,000, it is very tedious job. But again, if you go with a licensed distributed distributions like Cloudera or something, you can overcome this. And free edition of Cloudera allows you for 50 nodes. If you go 50 plus, you buy a licensed version of Cloudera Manager, and you will solve that kind of problems. So in terms of maintenance, yeah, you don't have a very good UI which will pop up and give you the error message that this node failed due to this reason. So if some node fails, you always have to go and rely on the log files. You go and read the log files for finding the failures. So that is in terms of maintenance. And if we say debugging is a bit difficult because each node is running on a separate JVM. So with Eclipse kind of environment, debugging in multiple JVMs is not possible. But still we have an option called local runner, which will help us debugging the application during development. So that we can explore and we can use it. So then we were talking about which industries is using based on the size and the region and all. So if we say the industry, banking and financial services, that uses the maximum like 25%, 15% in services, manufacturing, government. So almost nowadays all sectors are using that. And if at all we go by the region wise, North America is the dominating region which uses big data technologies like 59%, followed by Europe 19%, 17% in Asia Pac and Latin and Africa, so on. Then if we go by the size of the industry, large scale industry uses maximum, then mid and small size it's 25% and 12% in education, government and public sector. So that is just a very quick overview of all the slides that we discussed today, and we ran a live small example of word count, and we also discussed wherein the word count can fit in, like we took an example of telecoms which come up with a customized plan which uses the word count, plus the recommendation systems that we built also uses word count. So we took one example of YouTube, wherein Google goes and searches the keyword from the search history and it counts the number. So the highest number of hits that or highest count that a particular keyword gets, like for example cricket, then it will suggest for that user, it will give cricket related videos on the top. So that was a very quick recap that we had today. So anything else, something which you have, you can just
Okay, that was really great, Mufaddal, and we have really enjoyed the session. And Kishore said thank you to you for the session.
thanks, Kishore.
And guys, if you want to join this course, just click on this link which I have shared with you. And this is just a demo class today. So we have just touched the Hadoop today, and we will learn more with Mufaddal. And you have the link with you. You can click on that to learn more about the course. Okay. All right. Okay, Mufaddal, thank you very much. And thank you, guys. Ahmed is saying thank you. Kishore is saying thank you, sir. Manoj says thanks a lot, sir. Session was cleared. A lot of doubts. Okay, guys. Okay, guys. Yeah.
Thank you, guys.
Okay, guys. Thank you, and see you in the next batch. Thanks. Nishcha says thanks. Thanks, everyone. Bye.